I like this song. I think I like it. Hi, it's me, Scott. I haven't streamed for a few days. Is everything working? Got a microphone, got a bit rate, got some lights on. Hi. I'm streaming for a few days because I've been doing work, like a job. I'm really not into it. Really waiting to become Twitch famous. No, not because I want the fame. I just want the money. I don't even want that much money. I definitely don't need to be rich at all. Not interested in riches. Seems like a hassle. I just want to not have to do client jobs, probably. This job seems fine. Everybody seems nice. It's totally fine. It's just, you know, I want to do what I want to do all day and not what somebody else wants me to do all day. So anyway, I've been helping David with some Cosmic Sugar stuff, and this thing came up, this idea, and so I'm just going to do some probably kind of boring but pixel gymnastics in Unity because I have an idea I just want to try out. Because I built this pretty crazy save load system for him, and I think it's pretty good. It's not bad. It's pretty snappy. It does the job. But there's this precision problem with, you've got like a whole bunch of 32-bit values in memory, and you want to like write those out and load them real fast, and you potentially want to do it where it's really easy to get it to a shader and back and forth and whatever. So like, there's lots of ways to do that. I want to do it in a silly way, I think. But it's kind of cool. I don't know. It's one of those things that it's hard to tell if it's like, is it actually a good idea or is it a bad idea? The thing about it that's kind of cool, well, whatever, we'll try it. Let's try it. First, there's this guy. And I don't know what we're doing with this guy. Kind of weird wallpaper selection from Unsplash, but that's fine. The wallpaper, okay, there it goes. I thought the wallpaper thing wasn't working. Let's go with these nice pine needles. It's a little soggy today in Portland. It was a little soggy yesterday. I finally got my first vaccine shot. Finally. It took so long. Okay, what do we want to do? We want to probably just make a new Unity project for this. And I don't know if we need to put it anywhere special because I don't know if I'm going to keep any of this. So I think we just want a new... Let's do a 2019.4.25. Pixel pusher on. Do it on the desktop, and then if it seems like something that's worth dealing with, we will deal with it. So, okay, yeah. So to recap, David's doing these really complicated, really fancy particle systems. Got millions of particles. He wants to, we saw some of that on that thing, the web browser thing, High Score, where we could visualize the particle point clouds. So I was visualizing some of his point clouds. And for that, we used OBJs. Problem with OBJs is that it's a text representation of binary data, and so it's really verbose. Like, you have to use all of these bytes just to talk about a number that really would fit into 4 bytes. So if you have like some 32-bit float, which really fits into 4 bytes, you would have to set in text, it's like 0.372765, whatever. You might use like 10 or 12 bytes just to talk about that. So it's really inefficient file size wise. You waste a ton of space, but even worse, we found, when you're dealing with millions of particles and you're trying to load that file, deserialize it really quickly, or not even deserialize because it's just text data. When you're trying to parse it, let's say, you have to do all these string operations to try to convert those floats back to, or the string representation of floats into floats, and you've got to do that 3 times a million particles. It's slow. Like those kind of string parsing operations, things like that are just kind of slow, unfortunately. And so there's other options. One of them would be to use save it all in PNGs and just put your pixel data, or your positional data, in a pixel. The problem is you only get 8 bits per channel, and that's not that much resolution. You lose some detail then. You're kind of like really rounding off your numbers, and that's not ideal. So it's an 8-bit floating point value, or whatever you decide, however you decide to interpret that. But it's 8 bits per channel. So you could try to use EXRs, but EXRs seem to just be broken in Unity. And I tried this before too. There's just something wrong with them. It's like they always want gamma, or I don't know. Something doesn't work. I've seen other people complain about this too. So EXRs, you should be able to store just like linear 32-bit floating point values per channel into an EXR and read it in. It seems to be broken in Unity. So that's not cool. You could have your own arbitrary binary format, which is really not a bad idea. I mean, you just, you create this binary format, you save this binary format, you deserialize it, whatever. Like, it's okay. You have some in-memory representation, and you create a file from it. You can go back and forth between that relatively quickly, right? Like, ideally, almost as fast as you can load the file, because you can load that file into that in-memory representation. The maybe downside there is then like getting that back and forth to the GPU might be a little weird, whatever. Like, you know, it is nice to use images in that way potentially, just because GPUs love pixels, they love images. So, and there's always that cost. I mean, you always had to get it to the GPU. It's just, you might need to do something weird anyway, like write it all back to a texture anyway, or whatever. So there's more operations. I feel like there's one other option, and I don't remember. I guess it's like, use PNG and lose some resolution. Use EXR, but EXR is broken, so maybe you try to find some other EXR library to use in Unity. Maybe you can find a C# library. Whatever, look at all these polka dots. Ramiro Literal, I'm stunned by all these dots that you just put into chat. Oh, I see what that is now. Very exciting. It was wrapping incorrectly first, so I couldn't see your beautiful artwork. Very, very impressive. This is impressive artwork you've done. Stunning, really. Are those Braille characters? Did you do that in Braille? I wonder what that says. What do you think that says in Braille? It could say anything. It could be like the first chapter of War and Peace. Okay, anyway, yeah, so our options are PNG, and we lose some resolution. EXR, which is bad, you know, it's a problem in Unity. Some binary, just binary format, serialize, deserialize, and C#, whatever, some whatever. It's just binary. And then, or this weird thing that I want to do, which is some weird pixel gymnastics. That's not that weird. It's basically, I want to say that if I have a, say, 1024 by 1024 image in Unity in floating point, so I have a 32 bits per channel, that I would kind of split that into 4 quadrants of pixels, so a total of 2048 by 2048 of 8 bits per channel. And then that's something you could store and load or send to the GPU and operate on the GPU or whatever. And maybe that would be useful. Maybe. I'm still not sure that's the, you know, it's kind of a silly way to do it. It's the same amount of data that you'd store with the binary thing. The thing that's kind of nice about it is, even though it's weird, I think you can do it on the GPU real fast. I think we could just like write a shader to do the thing really fast. So what I think is the following. I think we just like make a script and we just start doing the thing. We just see what happens. So this will be like our pixel pusher. It's not really pushing pixels, but we'll ignore that for the moment. So, what are we gonna do here? I don't know the answer. Probably we're just gonna do some stuff like, for now, we gotta turn off code lens. That's the first thing we gotta do. We should toggle code lens easily, because it does exactly one useful thing. It does one useful thing, and that's all. It does this. This is good. Everything else CodeLens does is not good. Maybe I could go through and just turn off all of these individually. You turn this on and then turn these off. C sharp, C sharp. Maybe. Unclear. Okay, we'll know next time we have a merge conflict. So we want to say, for example, that I have a float an array of pixels that is what? 1024 by 1024 by 3, for example. I don't actually know if you can do that in Unity. As far as the texture format, you might have to do RGBA. Let's see. Unity graphics formats. Unity has changed some of this stuff too in recent history. Like, is this actually in 2019.4 or is this not? Yes, it is. Okay. So we want a floating point. We have these 6, actually. Huh. I don't think I realized this. That there are 16-bit signed floating point types. That seems pretty weird. Those are all signed. Weird. Unsigned float tack 10, 11, 11. So that's to get 32 bits across 3. And that's, I think, kind of funny. Like, that's kind of smart. That's another way you could approach this problem. Is just use less bits for blue, I guess. And then you'd have much more precision there. So that's not a bad solution necessarily. If you could then write that, you'd still have to do something fancy to try to write it. You know, that's still kind of a problem. But maybe not the worst problem. Like, that's actually interesting. That's interesting. Okay. But then what I'm thinking is, wait, isn't there just the type that is floating point and not signed, not weird, not packed in a weird way? Am I making that up? I thought there was just 32-bit floating point values. Is that what this is? That's a one component 32-bit unsigned integer format. Oh, I'm sorry, they're just not floats. Okay. So actually there is this. There is a 3-component 96-bit unsigned integer format. So we could theoretically go into that. Yeah, it's pretty weird. I don't know if kind of doesn't matter. Like, if it's 32 bits, whatever, you can say whatever you want about the nature of those 32 bits. The signedness is weird, but whatever. So because he's got pixel coordinates, so he definitely is doing signed values for sure. But I think I'm going to ignore that for a second and just say that we have an array of floats. We also have an array of structs that have 3 floats in them or whatever. It doesn't matter that much. I wonder what format he's using. It's 32-bit. I'm confused by the floats, to be honest with you. Because I thought there was a format that was just 32-bit floats. Doesn't it seem weird that there's not a texture format that is just like basically this, except not signed? Maybe that's all we want. So this thing, I don't think he's using the alpha channel. So it'd essentially be this graphics format, which is 32-bit R, 32-bit G, yeah. So let's just assume this. And float is 32-bit in, yeah, a float is 32-bit in C#, right? Okay, so we'll have these float pixels, 1024 times 1024 times 3 channels. There's lots of ways we could store this. This is like linearly. We could also have like a little struct. Would be another way to do it. We could also just make a texture that is like this. Maybe that's what we should actually do. Let's just do that. What are the texture creation flags? Who knows? There's a lot of ways to do this, but let's start with the texture and end with the texture, because I think that kind of makes sense to me. So do we not have graphics format for some reason? Do we have to be in yeah, it to be an experimental rendering? And we're still not happy? What are you mad about, everybody? You're just trying to spell this? Okay. That is a texture creation flags, which I don't really know what that is. Maybe it's like enable MIP maps or whatever. It's hard to tell if that's actually broken or if it's just... Yeah, whatever. Okay. So this is our... Wait, that's not the texture format I wanted at all. Oh, I just clicked on that and it took me to this one. Okay, got it. Sure. This is the one I actually want. So you can imagine iterating through this, like float texture. Isn't it like get pixels? There's a get pixels and a get pixels 32. And I can't actually remember. Does that give us 32 bits total, 30 bits per channel? I can't remember. I think that's on texture 2D, not texture. Get pixels in a color 32 format. Get pixels from the texture. But what is the type? Can be faster. That's low precision. So we want this. We want to get the pixels. Okay. Which is just, is this just a byte array? Oh, it's a color array. Okay, and then we want to just iterate through that. So, yeah, it's gonna be a little weird. The color, we'd want to create 4 colors by shifting those, so we'd be like, so what is the type of this? What are you? What are you? It is a float. Okay. So I'm being overly verbose here, but we're going to have to use our noggins a little bit, and I'm definitely not the best at bitwise math. So I'll probably screw it up. So basically what we want to do is for each of these end up with 4 integer pixels per channel. So it would be, you know, it's going to be int RA, or we make a new color that's now color int pixel A, you know, do this 4 times. Something like this. And what these are going to be, these don't, there's overload, so just give it this. Yeah, so we just want that. So what these are going to be is some number of pixels, or some number of bytes from our original dude. And we want to AND them to mask things off, which I don't really have to do this. Like, the way that I'm going to do this is going to be really explicit and not actually necessary, and I'm just assuming the compiler will figure that out for me. So this means I want the, I only need 3. The bottom, I'm basically masking these pixels off to say, like, only give me what appears in both. So this means I only want the bottom 8 pixels. This is hex. So it's going to say, give me the bottom 8 pixels. Now, then we need to shift that value over. This one's already where it needs to go. This one needs to go over by 8 pixels. And this one needs to go over by 16. And actually, I did this wrong, of course. But first of all, these are only... I'm confusing myself because these are only 24 bits, really. Because... No, that's not right. These are 32. I'm just only using... I might be making this harder on myself than it needs to be. By not using the 32, like using only the RGB, is a little confusing. Okay, yeah, I'm doing this wrong, basically. These are all the same. And then these, you know, they're effectively shifted over none. I was just confusing myself. It's fine. And actually the shift goes the other way, right? And you could do this other ways, like shift and then mask, but I feel like it's a little more explicit because then you just know, like, I'm getting the thing that I want. So how do I do this in such a way that I'm sure that I'm Because I don't actually want to cast this. I just literally want to get... Because I don't want to convert. I want to just store it. So this is a little tricky because I don't think I want to cast it. I truly just want... I don't actually know why I can't do that. Doesn't that seem weird? Like, what does it care? I'm just worried if I cast it. Right? Like, how can I do this without changing the internal representation? Like, I very specifically don't want to mess it up. Yeah, you could do something like this. But I want C# anyway. I don't want to convert it. I just want to mess with it. And I specifically want it. I mean, there's this thing, this reinterpret cast. So the union would be fine, but that's just not the thing that I have. You know, I don't have a union here. I guess I could cast it to... Can I cast it to that union? That'd be sort of interesting. Like, I don't care, you know, I don't care about what's going on in there. I just want the bits because I want to grab them and I want to put them back. I don't care about the fancy, you know, the fancy wave floats or short memory. Doesn't matter to me. I just want those bits. Just give me the bits. Give me the bits. I don't know if I can cast to a union. Starts to get a little fancier than I wanted to be here. Are there not unions in C#? I don't even know, actually. The float window. Can you do something like a union in C#? Probably not. Interesting. Explicit field layouts. Can I do this bit converter? Maybe that, okay, maybe there's a way that I'd want to do this in a language that isn't this language. And maybe I should just try to do it in this language. Like, can I use bit converter to... Weird that there's doubles in here, but not floats. I mean, I could do it. I could do a double as a 64-bit integer, I guess, and just not care because I won't really look at the... Isn't it kind of weird that there's not a... two-byte conversion, get bytes, and then do the double, but it's a float, so what happens there? There's like nothing here to go. You just don't care about floats. Just don't care about floats. Where you live, bit converter. Oops, where do you live, bit converter? System. I never liked totally using system. Okay, so we'll do a bit converter.get bytes. And this is going to return like a 64-bit integer. Or wait, what was that other thing? I thought there was a thing that was double to int 64 bits, which returns the long. Not really what I want, you know? Not really the thing. But that may be the thing that we have to work with. And then these jerks will just be longs. So these are 64 bits, and I just don't care. It's more... Feels a little silly. Feels super silly, actually. It feels like something bad. Feels like this is doing something bad. Because this is a totally new thing now, you know? Like, I've got all of this memory, and now I'm doing some goofball thing to, like, convert it to something else. It's not like I'm just pointing to the same place and treating it as bits. That seems pretty lame, actually. And there's not just a, like if I want a 2 int 32, that probably just wants an array of bytes. Yeah. I don't know. I just want to look at your bytes, man. I just want to look at them. I want to look right at them. But C# kind of, I don't know. Maybe I just don't know how to do it. But it sort of just feels like, well, too single. Single precision, right? How did I miss that? But there's not a single, yeah, there's not this trick. Two 32, but it wants like a byte array. So it's sort of annoying that there's not a, so of course, yeah, I was looking for float, but that's single. Isn't it weird that there's not a way to do this thing? Because it's just going to... turn it into a byte array. Which I don't really want. I don't want that. That's not what I want. You know? It's just not what I want. Unless there's some trick. Is there some trick I can use to like do that and then do a 2int32? But there's not like some kind of... Well, there's a read-only byte span. What does that even mean? I don't even know what that means. Well, that's what I want. How do I get a read-only span? How do I get a float to a read-only span? Because that's what I want. Is that a thing you can do? Can't convert. I don't really understand that. I don't know what this thing is. Oh, I will want it. So read-only span. How do I get you? I want you. A read-only span of type, and then I give it an array of that type, or oh, this is like .NET 6 preview. That's fancy stuff. That seems cool. It seems like that's getting towards what I want, but we may be living in the future. Maybe we can't have that. Then .NET 5, .NET Core, .NET Standard 2.1. You know, like if I just want a like a double to read-only span of... What does that have a type? Can't it just be a read-only span of bytes? That's kind of what I want. That's a two double. But I want my double... I do this? I don't know if I can do this. I don't know what I'm doing. You know? Like a read-only span. Although it's weird that you would say that it's a new read-only span, because you're like... It's almost like this is a pointer. Where do you live, read-only span? Who are you? I absolutely don't know what I'm doing. But I'm kind of into this if it, you know, if it does the thing. System.readOnlySpan. It's .NET 5. That's probably not good. It's probably not in here. What are we, like .NET Framework 4? Included system. Field is read-only span. How do I get you? Can I have you? Do they want it? Geolocation string builder. Maybe I just can't have this. System.memory. I want that. I want to play with that. That seems like a really interesting thing. Can I have span? If I can't have read-only span? Is that a thing I can have? You never let me have anything. .NET Standard 2.1. Oh. So two things, actually, I guess. So it's not here. Is it here? I guess probably no. But it kind of seems like span should have been. You know? Man, I want it. Okay, so I just can't have that, even though it seems cool. Because it's not in this stuff. And regular old span. Regular old, boring old span. Also not there, presumably. Yeah, okay. So this is lame. This feels not fast, but whatever. It feels like the way we have to do it. So, we basically do this 4 times. Now I'm mad because I want... C# just doesn't want you to like think about memory. C# just wants you to pretend like memory doesn't exist. And I'm definitely not the best at thinking about memory, but I'm trying to get better about it. And C# is just like, don't. Just pretend it's not there. Okay, so we want to do something silly here now. And now we want to, you know, bump over 8 pixels. You don't really have to do this. You could always just mask whatever's at the bottom after shifting. But I don't know. Maybe this is terrible practice. This makes it easier for me to understand what's going on. Even though I can't use my own editor. Because you could do this, if you did this in the opposite order, you could just always mask the bottom 8 bits. But to me, it's like, no, I specifically want the bottom bits. I specifically want those bits. I specifically want those bits. So it just feels a little more explicit to me in a way that I like. I'm sure plenty of people will look at that and be like, what are you doing? That's terrible. Maybe it's slower. If I had to guess, I would guess that the compiler is going to be smart anyway and do something to make it better. Anyway, so the idea, and this is weird, what we have done is weird, but we have taken this color that previously was floating point, and in fact what we should do is probably make this a color 32. Probably. Problem with, yeah, this is a little annoying. Like a color 32, we have to have a color. So what are you mad about? Can't convert from long to byte. Well, we should be able to now, because we've just done the thing. So cool. This seems very verbose to do the very simple thing that I'm doing. Okay, so I think about the way it is annoying. The way I'm doing it, it makes it annoying because it's just so different for all of them. So like going down and now applying this everywhere else, it's kind of obnoxious. The multi-line editing and it doesn't feel quite there. I understand why I can't just, yeah, it just doesn't work exactly as I would expect it. Okay, so you all are crybabies and you all want 0. It's a little annoying that we need this alpha, but whatever. I mean, that alpha's in here too. We're just not paying attention to it. I mean, honestly, we're going to do all of this like it is. It doesn't cost us any, you know, we're doing all this work anyway. We might as well do the alpha also. So say these were all very floating pointy. Because we're already doing the work. Or almost all of the work anyway, you know? So just doing a little more is not that big of a deal. So I'm gonna type this all over again. Whatever. Oops. Good grief. Okay. Can we do this? Probably I'm not going to do it right, but let's try it. Because I want to just say Control V, highlight all of this. Control V, paste it there. Nope. Did I do it? Why is this color 32 mad? What are you mad about, buddy? Are you sure about that? Oh yes, because I have typed over somehow. Good grief. Yeah, I like highlight this. I just don't, I'm missing something. Kyle. Yeah, I had to. Because I couldn't stream very much this week. How's your weekend? This is a stream where I just fight with the editor over and over again, so that's cool. So we did that, and then this one just wants one of those. Okay. Starting to, I feel like I'm like getting a little better with the... Wrong. Pete, wrong. Wrong. Everything I'm doing is wrong. Just type that. How about? So, this doesn't look right. Looks like I did something wrong, but maybe it's just that. No, I did the same thing here. How? Don't know. I feel like my fingers, like I've got some kind of muscle memory that's working against me. Okay, we get this 32-bit float here. Now we've got these 4 new pixels. So, what do we want to do? What do we want to do? Can you tell me? I think we want to do this. We want to make an int texture that is a new texture 2D that is float texture dot width times 2 float texture dot height times 2. We're definitely going to be assuming these are square. It's going to be a graphics format R8. So this is, we want RGBA unsigned integer. This is unsigned normalized. Is that what we want? Is that what I wanted my whole life? For normalized format. Oh. Well. Is that what I want? It doesn't matter. It doesn't matter. The bits I put in there aren't real. They're not real. It's probably the same. You know, the data that's in there is the same. It's just when you look at it, it's what's going to come out. So we'll just not do that, and we'll just say that it's a uint. Like this. So we'll have a signed float that will, yeah, turn up like this, right? Okay, here's where it gets goofy, is how to address this. Because I think we want to break it into 4 quadrants. You know? So we probably need to do the thing that you would think I would know how to do because I've done it 17 million times. But I don't remember. So it's going to be x and int y. And int x is I mod float texture dot width, and int y is I divided by float texture dot width. Is that true? I think it's true. I think it's true. Then we also need a color and pixels. It's so, I don't even know how to explain it. It's so complicated. It's not that complicated. So, you know, binary, right? We're all fans of big fans of binary. So let's say that I have a 1 byte number, say the number 1. In binary, it's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8. So this is like, that is I've only set 1 bit, but this is 1 byte because there's 1, 2, 3, 4, 5, 6. I did too many. Wait, 1, 2, 3, 4, 5, 6, 7, 8. I have too many. So that is 8 bits, which is 1 byte, and that's a number 1. And that's great. If I was making a PNG, when you think about color, you often think about RGB, RGB. And you might say, well, I want each of those to store 8 bytes. And at 8 bits. So this is 1 byte. Basically, you can count between 0 and 255. That's all you can store in 1 byte as an unsigned integer, or it could be negative 127 to positive 127, whatever. But as far as an integer, this is what you can count. And so I might say like, okay, I've got 8 bits for R, and I've got 8 bits for G, and I've got 8 bits for blue, and this is going to let me store my red, green, blue values. So when I looking over here in Unity, if I want to set a color, I can look at R 0 to 255 because it's saying these go 0 to 255 because that's all I can store in 1 byte. So if you look at this color, for example, means I have 155, 2480 in. If we look at this like it's an unsigned integer, we could also look at it normalized and say that it's like 0.5, 0.5, 0.5. And in hexadecimal, that looks like this. In binary, it would look a different way, but it's all the same amount of information, right? We are never storing more than 32 bits with this because we have 8 bits per channel. So 32 bits, we just have like 32 zeros in memory that we can store stuff. And that's great unless you need more precision than that. And so Unity will let you make a texture that it uses 32 bits, not for all of these total, but 32 bits just for one color. And so you can have really high precision colors. So like HDR often uses 16 or 32 bits because you can have a really high range of color stored. Whereas this is 32 bits total with 8 bits per channel, you might have 128 bits to describe a color where you have 32 bits per channel with color. Anyway, why do we care? When you want to save or load from a file and you want to save or load from an image file, Unity has some handy functions like encode to ping. And it will say, it'll take this texture that it has in memory, this big array of 8-bit numbers that are RGBA, 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 RGBA. Those values we just looked at, they're literally these values, just one after another for every single pixel. And it'll put it in PNG. A PNG can only do RGBA 32 or RGBA 24 if you don't count if you just throw away one of your channels. And that's as accurate as you can be. So if you're in Unity and you're actually working 32 bits per channel with 128 bits and you decide to save to a PNG, you lose a ton of information, which is maybe fine for like a picture. But if you're trying to encode data in your PNG, you might be really sad because you just lost a ton of information. Unity does have some other texture formats. One of them is called EXR, and EXRs are specifically designed to store like really high dynamic range numbers and can store 32-bit floats. Unfortunately, it seems like the EXR handling in Unity is broken and dumb, and it might be on purpose, it might be by design, that it doesn't store things linearly. It looks like if you put information in there, it will not come out the same way as you put it in. You put some information in, like some totally different information comes out. It's not cool. It's actually uncool, one might call it, that Unity would do that. So that kind of sucks. And then as far as what else Unity can write, Targa is also just RGBA 32. So you can't store any more information there. JPEG is also going to be 32 bits per channel. So you're kind of in trouble if you if you want to save a bunch of highly detailed color information from Unity, because these 3 formats don't support it, and this format just seems to be broken in Unity, which is dumb. What is this? Ping gamma runtime load behavior. Cool. And there's some flags here that are supposed to let you do things. Like you can say, no, I specifically want float, whatever, but I don't know. It doesn't seem to work. It seems busted. Seems straight busted. So what I want to try to do is to say, I've got a texture that's really detailed, and every single pixel of it has 128 bits. Even though I know when I save it, I can only have 32 bits. So I'm going to do this thing where I've got this texture, and I'm going to run a process that will split it into 4 textures, and it will take pieces of the bits, like sections of the bits, and put them where I want them. Like essentially in 4 different parts of the PNG. So the PNG will be twice as big, both width and height, but I will be able to, which means it's technically 4 times as big, but I will be able to store 4 times as much data in it. And then when I put it back, I can like mush it back together. So maybe it's a terrible idea. I don't know if I explained that very well. This is for David. So we were doing that hot, what do we call that thing? High score? .github.io high score. Yep. Excuse me. So we made this thing. What is that other thing? Gallery.html. Nope. Gallery/index.html. Well, what did we call it? Maybe I didn't push that yet, actually. Anyway, this is like 1 million particles, I think. Maybe this is less. This might be just like 100,000. That might be 1 million particles. So what David is doing, and which is not like an uncommon thing, is to say, if you have a texture, you could use the RGB data in that texture to track the locations of a bunch of pixels in space, and you can do kind of crazy particle simulations really, really, really fast, which is handy. Because, you know, of course you want that. Of course you want fast particle simulations. So the problem is if you save that to PNG, like I said, you're going to lose a bunch of information. You've gone from maybe 128 bits of data per pixel down to 32 bits of data. And so you just can't talk about space in as much detail anymore, which is kind of a bummer. So that's the reasoning for this. I don't know. I don't know if it's a really good idea. We could make a totally custom binary format, of course. But I was just interested in trying this because I was just kind of interested to see how we could do it in C#, which so far the answer is it's annoying because we had to do this bit converter stuff, which seems dumb. Like there's some memory that has a float value, but I don't care. I just want to talk about the bits there. But this is now, I like maybe made a copy of it. It's like using new memory for this. Whatever. I don't know. It's dumb. But we're not totally dumb. This is scoped to this for loop, so maybe it's smart enough. Presumably the compiler is smart enough to not just like, yeah, it's got to be smart enough. Not double, more than double. Not only take all the memory I'm using for these 1 million particles, but then like double that to store it again, but then also double it again because it has to store it in double precision and not float precision. So I don't know. Kyle, sometimes you just do things because they seem like they might be interesting. And maybe we did this, like this is, I feel like we're almost done here. Actually, except for figuring out this pixel offset problem. Because we're gonna write, it would actually be easier if it was just like a single ping image that was like 4 times as tall, because then you would just add an offset of the total number of pixels rather than saying a 4x4, or say it's, yeah, 4 times as tall would actually be the easier way to do this. Is that a dumb idea? Because doing it the quadrant way is a bit annoying because that means you have to convert from your index to XY, and then, what if I did? Okay, we're just gonna try this. If we kept the width the same, instead it was just 4 times as tall, I think we can save some math. And I don't think anybody cares. We don't want min maps. Nobody cares if we do this. 4 times as tall seems better because then I can do something like this. You're gonna love this. You're gonna love it. So this means that I can say int pixels I plus, so just I. Maybe to keep these consistent, we'll do like I plus float texture width times float texture height times 0, 1, 2, 3, 4. Something like this. Oops. Are you serious? It was that bad? Oh no, really? So what you're saying is I should have just submitted the 15 different things I should have done? Really? Wow. I feel like well, what was the other category was games. So the other was for games, right? A spin wheel, a random game played by the streamer and the viewer. That's okay. Kyle, here's what I'm going to say. It's your fault that I didn't win. I'm blaming it on you. I'm 100% blaming you that I didn't win. And that might seem harsh, but it's definitely your fault. It's 1,000% your fault. Because you waltzed in, you just waltzed in off the street, and you told me that how do you even pronounce that? Lorian board. You told me that it already did like triggering things with channel points, and it took the wind out of my sails and made me give up on that project. But now I'm pretty sure Lioran. That I'm pretty sure, looking at how bad those winners were, that if I had finished Sleepy Keys, I would have won. I would have won. Sleepy Keys would have won. Sleepy Keys would have been the winner. No question. No question in my mind. No, that next year there'll be some other dumb thing. What an outrage. Oh well, that's fine. Here, what I learned from that whole experience is I think channel points are dumb, and I didn't actually like them very much. Apply? How do you do this? That's to get the pixels. You have to set it again? I forgot how that works. Wow, I can't believe this. Sleepy Keys was going to be so good, and then it actually wasn't that. It was okay. It was just okay, but it was better than a thing that filled up a cup of water. I'm outraged. I could have used that $10,000. So you don't. Oh. I thought you had to do get pixels. So it'd actually be a set pixels and then an apply. I think. Gonna work. Don't know. I haven't even tried to run anything yet. I think this might work. Heat was runner-up, so it was like $1,000. It was definitely not worth it. But then Twitch hired me to do a thing with Heat that kind of helped make up for it. And then Twitch was supposed to hire me and pay me $50,000 or $60,000 to do Heat stuff. And then they totally flaked in a way that I'm still outraged by. But, cool. 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 Okay, so we can't use this, actually. We have to do unorm, I guess. Maybe I hate Twitch. I should go to do like just do public broadcasts. Like PBS. Do you think so? I think they're not going to do channel. I doubt they do channel points next year. You know, last year was AWS. This year's was channel points. I did get an email for a new thing. Let me see what it is. Somewhere. Maybe I got rid of it. Ah, yes. Cassie from DevPost says, since you've shown interest in previous AWS challenges, we wanted to let you know about the latest virtual hackathon. Submit your idea to get a shot at making it to round 2. It is the 5G Edge Computing Challenge with AWS and Verizon. Submit your idea to the 5G Edge Computing Challenge. The best ideas will move on to round 2 with special access to AWS Wavelength and Verizon 5G. AWS and Verizon are teaming up to bring a one-of-a-kind hackathon to the global developer community. Use your creativity, technical knowledge, and problem-solving skills to gain access to state-of-the-art technology. Like that was a little redundant. What applications can you build with the power of AWS on Verizon 5G? From self-driving cars to instant medical diagnostic results, the future is bright and super fast. So round 1, submit your ideas that you plan to build. Judges from AWS will review your submissions and select up to 200 to advance to round 2. Round 1 winners. So do you win money for round 1? Kind of seems like no. Round 2. Build out your round 1 idea. Oh, this is due like tomorrow. I wonder if they didn't get that many people. And that's why they're plugging it. Build out your round 1 idea with special access to AWS Wavelength and enter your completed submission to DevPost. Round 2 winners announced. Hackathon prizes. First prize, 50 Gs. That virtual avatar, but it needs to be 5G. But what if I just made a physical robot that just sat in the park and talked about Wikipedia all day? There's some robot that just sat in the park and just talked to you about whatever it was interested in and didn't really pay attention to you. It could say like, did you know? And then just like pick something. I don't know. I actually don't know what Amazon Wavelength is, though. What is Amazon Wavelength? Amazon Wavelength. And how do they like give me hardware? What do they actually give me? Amazon Wavelength deliver ultra low latency applications for 5G devices. AWS Wavelength is an AWS infrastructure offering optimized for mobile edge computing applications. Wavelength zones are AWS infrastructure deployments at the edge of the 5G network, so application traffic from 5G devices can reach application servers running in wavelength zones without leaving the telecommunications. I don't actually know what this kind of doesn't make that much sense to me. It's available in 10 cities across the US. What are the cities? And surely in Seattle, right? Use cases. I like the idea of actually like a robot apostle, but maybe it would have its own its own robot religion. Okay, this is some use cases. Connected vehicles. Interactive live video streams. Interactive live video streams. That's my whole thing. Interactive live video streams. Wavelength provides the ultra-low latency needed to stream high-resolution video and high-fidelity audio, as well as to embed interactive experiences into live audio streams. Or live video streams. I don't know what that means, actually. This is like a terrible use case. Provides the ultra-low latency needed to live stream high-resolution video and high-fidelity audio, as well as to embed interactive experiences into live video streams. What if that means that there's like a data channel on in the live stream? That doesn't exactly make sense here. Real-time gaming. ML. This says submissions open soon, but it sounds like submissions are I'm pretty confused. This says that must be submissions for round 2. So round 1 is over like today, tomorrow. So you submit your ideas and they're due basically tomorrow night. We get that video monster, if you think. I don't know if that's exactly what they're looking for. Because it feels like you gotta like go like stick it in a park or something, right? So that but what do they give you anything? Like, what applications can you, like, if you get through round 1, build out your round 1 idea with special access to AWS Wavelength and Verizon 5G. So where is it even in Portland? AWS Wavelength, the length cities. Excuse me. Where is this? Ten US cities. Why isn't there just a list of them? Good grief. Atlanta, Boston, Dallas, Las Vegas, Miami, New York, San Francisco, and Washington, D.C. Wait, no, it's not 10. This sucks. Just why isn't there just a list? Come on, Amazon. Come on, Amazon. Maybe I should have a robot in the park that tells everyone that they can get millions of followers. So how, I don't know, I still don't exactly understand what this is supposed to be. But it seems like you've got to be in a zone to do it. Right? Right? I'm kind of astounded that there's just not a list of cities. That was only 8, and it's supposed to be in 10. Where is 5G Edge available? Okay, Atlanta, Boston, Dallas, Denver, Las Vegas, Miami, New York City, SF Bay Area, Seattle, I guess that was the missing one, and Washington, D.C. Let's view the coverage map. How do you, I don't know. This seems annoying. I don't either. I think they don't know either. I think they're like, we built this thing, we don't know what to do with it. What are we going to do with it? I think that's the same thing happened with Twitch and channel points. They're like, I don't know. What are we doing here? Don't know the answer. Okay, let's do the following thing. Let's create some quads. Everybody's favorite primitive object. So what we want to do is we want to say, we just want to prove that we can go kind of A to B to C. You know, we'll put some amount of data in the first quad, and hopefully it comes out properly on the other side, because we'll have to build a decoder too. These all have mesh renderers, I guess. Oh no, no. The main texture, right? Equals float texture. And texture. There's always a million things on dev post. They usually don't seem very good. Maybe I should scope it out. But I don't know. I've got this project that's going to run for 8 weeks that is going to take a lot of time and attention, and so I don't know that I want to get into a lot of into a hackathon that would take a lot of time. Mesh renderer A, mesh renderer B, mesh renderer C. Kyle, how am I going to get all my income from Twitch without buying a hot tub? I don't have to be rich. I definitely don't need to be making millions of dollars. I just want... Should I just make 100 apps and sell them all in the App Store? Is that the solution here? Pretty weird. We need a material, probably. That can just be unlit. No, just unlit texture. Unlit texture, thank you. I'm gonna make the big bucks. Is that the secret? Hold hostage. I think heat is better than the video monster. I just don't want to work on it, really. This is the whole problem here. Why did that still seem lit? That's weird. Oh, maybe it's now we're happy. Okay, because it just got a bunch of zeros in it. So here's what we got to do. We got to put a bunch of synthetic data in the float texture. So that's like, we got a float texture in, we got a float texture out. That was not the way to do that for sure. Monetizing things is just so boring. It's so boring. Okay, so we got 3 textures. Okay, we'll get a hot tub. That's fine. My friend Lola lives in Seattle, and she recently bought a hot tub. So what I'm thinking is we get up there, we go visit Lola in Seattle, and we do this AWS challenge because we'll be on the whatever, their Verizon 5G Edge Wave, whatever. Splashies? Is that the thing? Okay. And then we'll make some splashies. It's going to be great. It's going to be great. It's going to be pretty great. Okay, so we have we have whatever our texture in is, or the out texture. We need to like stick some synthetic data into the float. Our float baby. How do I want to do this? We can just do this. I'm not sure if there's a colored at random, but we can just do, you know, float. This is kind of a silly way to do this, but it's okay. It's okay. Don't freak out. So then we can say, well, no, we have to have the pixels. What am I saying? We have to have the pixels. Because we're gonna talk to them. We're gonna put stuff in there. Then we want float pixels. I don't think that's true actually. We can talk straight to the texture. I think it's just slow. So let's just do it this way. Float pixels I equals random dot. Can we do a random color? Sure. My whole new jam, these arbitrary scopes, all about arbitrary scopes now. Or just like organizational scopes, kind of into it. Okay, so does this work? Who can say? I don't know. Should just be chaos. Yes. So we got chaos here. We don't seem to have chaos here, which is not good. I'm just going to come out and say it. So why would that be? We've got all this stuff. We got a million or whatever, you know, a million-ish pixels. We made this. It's 4 times the height. We got all these pixels. We did the whole thing. We got all this. We set those pixels and then we applied. So what did I do wrong? Okay, well, I'll tell you one thing I did wrong was this. Because I forgot, because we were copying and pasting a bunch. Thought we had this, and then I must have pasted over it. But that wouldn't really... that wouldn't explain seeing nothing. I don't know what all these alerts are. Am I getting more emails about fun hackathons? No. Getting boring emails about health insurance. I mean, it is incredibly possible, if not probable, if not guaranteed, that I've done something absurd here. You know? Like, I don't know if I honestly don't know if this really does the thing I want it to do. It may not. Okay, so that sort of makes sense. So what did we do wrong later? Because presumably this is a truly random, like we have extremely, I don't know how random, you know, maybe it's not actually doing 32-bit values or 8-bit values for the, no, you think it, surely it is. Surely it is. Maybe it's not. Maybe it's not. Let's just check. New color. So what did we say? We said assigned float, but it's not normalized. So like, what does that really mean? Does it have to be randomized between 0 and float max or something? Or like assigned float? I don't even know what platforms support these. Graphics format. Float. There was that signed 32-bit. This is the one. The thing is, I just want some random. I want a huge random number. I want a random 128-bit number, basically. This sucks. Like, if I could just do stuff, I don't know how to do this in C#. Because I want to just say, like, I just want to touch some bits. I just want to do some stuff, you know? Like, this is why I hate including system, by the way. It breaks Unity Engine random. So John, random.range. Like, I'm just wondering if it's only doing the bottom 8 bits for the random color. I don't know. That would seem a little weird. In fact, that wouldn't make very much sense at all. I bet that's not what's happening. Because, like, these are signed, or they're just float values, not signed. But when they go into that texture, I just don't know how to do that. Like, how can I guarantee that I have a 32-bit. Like, it kind of sucks that these are colors. I sort of wish they weren't. Like, if they were just, which I guess I could do, instead of get pixels, can I like get bytes? Get pixels. I get raw texture data. Well, that's actually, maybe that's what I should be doing this whole time. Because then we can get the raw texture data. Okay, I have an idea. Maybe this is what we should have done to begin with. So we get a native array of color 32s. What if I don't want color 32s? I guess it is a byte array. Okay, so call the apply. Does not allocate memory. The turn native array directly put to, okay, that's awesome. So I don't have to set it. I just call apply. So the question I have is, can I like put whatever type that I want? Like if I put a 32-bit integer, you know, whatever. Can I do something like that? Or so now is that really okay? This may be the thing I've actually was wanting the whole time. So maybe we actually have the thing. So this will give me a native array of int. Okay, is this may be the secret? Wait, what was it? Unity Engine or Unity.collections? This could be cool. It could be cool. I don't know. So we wouldn't want that. We would want a native array of what if I have a float array.length? So I just need a random number, like between 0 and not math.random. It's Unity engine.random.range. What do you think of that? Why does this think it's a float? That's weird. Why would you think this is a float? What? Oh, do I need to be like a uint? Like... Okay, sure. Sure. Why do you think you're a float? What? I mean, is there like an int max or something that I can use? That seems like the biggest number that I could have in a 32-bit integer. 32-bit unsigned integer. Why couldn't that be the biggest range? Right? Should I get... Maybe I shouldn't do random this way. Just cast this. Is that not right? Something like that. I don't know if that's actually right. Okay, we learned something good, though. The native array stuff is good. So let's run this. I don't know if it's going to do anything differently, but that means we can do the lower part better. Weird. Seeing patterns in there, man. See the patterns, man? What does it all mean? It kind of looks like MIP maps kicking in. Which is not a thing we'd want. We don't want MIP maps on this. Doesn't seem like there's MIP maps. Is this the filtering? I guess it's just the filtering kicking in. We didn't move the camera. I don't know. That's weird. Okay, so now we've made it worse somehow. It's the raw texture data, and then we stuck some stuff in there. And that worked. Like, we see it. We see the stuff. It looks very random. It looks extremely random, you know? So, I think I want to do the same thing here. For both the float array and the int array. This will just be the same. So now we have an int texture. We've got all this fun business. We're addressing those pixels directly. We don't have to do any dumb thing because we don't care. We just know. We're just saying, hey, you got 32 bits there. Let's do some cool stuff. We don't need to do this anymore. Well. Oh. We don't care about this. Okay, actually, this is weird. This is what's going to be a little weird, though. Oh, right. Okay. This is weird. We gotta think a little bit about how to handle this. Unless we cast that to a uint 128 and then we grab the pixels that we want, that's a thing we could do. We could say, first we wanted to treat it as uint 32. Okay, wait. I gotta think about this more now because we may be doing this totally wrong. Or wrong-ish. These are like 128s. Is that a thing? That's what we really want. I want a 128-bit int, but maybe I can't have that. So actually what I'm doing is this is a random value per channel. That's not for the color, that's per channel. This is per channel. There's a 32-bit integer. So that's a little tricky because we just have to step 4 at a time, I guess. Because our RGB values, oh boy, how do we do this? This is kind of confusing. I guess there's not a nice 128-bit data type we can conveniently use here. Okay, so we can just do this. But then each of these is going to be that same thing, but with an offset. Let's count 4 at a time. Oops. I forgot the thing. The increment thing. I don't know. Doesn't matter. Okay, 3. So, who's slacking me? It's David. I should show him the thing that I'm doing. Okay, so this is weird for sure. So now we have the 4 float pixels and we have them from the native array. We're like looking right at the texture data, and now we want to stick this in the new those new positions. But these are now 8-bit values. So when we look at these are here's what's pretty confusing is that this is I would be like candy to get this as a 32-bit. I don't know. This might be really I'm also making it even harder than it needs to be, or now I am. So I had it like sort of laid out in an easier way, but now I'm trying to do it where you do this get raw texture data and then you just are like directly manipulating the texture memory. Also, I realized 4x4 is not the way to do it. You want it stacked because then you don't have to like go back and forth between index and XY. You just want to do, because if it's stacked, all you need to do is just offset it by the total number of pixels every time. But now I gotta try to wrap my head around how to do this. It's pretty weird. It's a pretty weird thing to do. But I think actually, you really do just want to stick. You want an 8-bit value. Yeah, this is a confusing thing. So the bottom 8 bits seem like they're right. because this array is the same resolution. It's just we also need another offset. So like, I'm gonna comment these out for a second because that's a little tricky. I don't know if this is a good idea, David, but it seems kind of cool. But doing it with these arrays is kind of nuts. I don't think I've ever done this before. Maybe I have actually. Well, it's the native arrays. So I've definitely done stuff with native arrays, but not in this particular way. So what do I want? I want to say in a place that was previously 32 bits, like I need to do this now. Where these are now man, this is really weird. I don't know what they'll look like. They're gonna look weird for sure. So I need these values, but then I need to OR these together and bit shift them again. Okay, so I need these, but I need to OR them binary bitwise OR. And I need to shift them, you know, that would be 0. This is backwards. That's backwards. We gotta go. These need to shift right. I'm not the best at bitwise. 24. Something like that. I mean, clearly that's broken. That is a crazy looking line. What have we done wrong? Okay, so that's not a major problem. So this whole thing we now need to cast. Well, that means we don't need bytes anymore. So how do you feel about this? We're taking the bottom 8 bits of the red, green, and blue channel from the original float array, and then we are combining those in a 132-bit 2-bit number and sticking it in our array. Is that going to work? That is not what I would have expected. So first of all, that okay, I definitely screwed that up for sure. This thing should really be 4 times as tall, you know, because it's so that was weird. I mean, oh, crazy moray pattern. What's in here? Look at how weird that looks. So my offsets are definitely bad. Yeah, okay, I gotta really think about like the structure of this. Because that's not right. What I just did is obviously not right. Really what I probably want. So another way for me to think about it is if I got this one as 8 bits, then I would know like, okay, I'm getting a thing out that was 32-bit and I'm putting it into a place that is 8-bit and it can have these offsets. That's probably a little easier to wrap my head around. So we'd say those were 8-bit. And then we don't have to do this. And so just one of those would look like this. I should have just done the shader version of this first, because I bet the shader version would have been easier. But here we are. Okay, so then we will say wherever we were, and then plus those offsets again. And just to be really explicit, let's be overly explicit about where we are. We want to do this, yeah, sure. Before the offsets. I think the shader version of this could be so easy. Especially with the 4 tall thing. Can I not, is there not a uint 8? Is that not a thing that exists? Is that just a... Is that byte? That's just a... Okay. Is byte... I think byte's already unsigned, right? C# data types. Show me them. Show me them all. Basic types? Where is the list? I would have thought there would just be a list of types. You? That doesn't look like all the types. Just show them to me. Integral number types. Okay, byte 0 to 55. That's what we want. Unsigned 8-bit integer. That's what we want. Okay, so now we probably do have to cast this to a byte, and that's fine. Because we're only using the bottom 8 bits and you can see that from my very explicit masking, we're only using the bottom 8 bits and we're not shifting them all. Pretzel Rocks is a royalty-free music streaming service, so I always use it on stream because then you don't get copyright strikes on YouTube. Or you're not supposed to, even though I have had that happen with one dumb band in particular from Pretzel Rocks. That looks okay. Why would that have happened? Why did this happen? Why would that be true? Oh, is this, it's indexed down here in the corner, right? Are textures indexed lower left, lower right? Or lower left? Starting lower left? Or are they indexed here? Do you know where pixels start counting in Unity? Do they start down here or up here? Down here? Up here? Down here? Up here? I don't know. I thought it was upper left also. But I have the raw texture data, so maybe the raw texture data starts lower left. That's what it looks like anyway. So what all I would have to do then is say for the next one, now we just need to know the offset. And now we need to say this. Wrong. Now we need to say this. I don't know why it gets rid of the thing that I have there, but hey. Okay. And now, okay, this is where we got to start really thinking about this. So now we've masked those, yes, and now we want to shift over 8 bits. And I know there's definitely more concise ways to do this, but I'm trying to be really explicit so I see what's going on. There's no uint31 because I obviously hit the keyboard shortcut that decrements everything. Which I should, really silly. I think in Vim, U is undo, but Shift U is like increment. Weird. Okay, that doesn't look right, does it? Did I do something wrong on these? Oh, yeah, that's not supposed to increment. What is your problem? Okay. That doesn't increment. Okay, so this should be... Yeah, really, this seems like it's indexed lower left. That does not look like it is offset enough. That's because this isn't enough. It's got to be times 4. Not you. I feel pretty confident that I'm making this overly complicated, but is it not times 4? Because the width and the height would just be the number of pixels, but we have 4. No, I did it again. Get out of here. Maybe I accidentally turned on caps lock. Okay, you are times 4. If I could do a 128-bit type, that would make this easier. Okay, so that works. It's pretty weird that the like bottom 8 bits don't have very much. Like weirdly looks like the bottom 8 bits don't have as much entropy. I don't know exactly the word to use there. Like as much randomness. Let's do the remaining 2. That could be the way we're generating our random numbers. So we'll try not. Well, you know, we'll do a version of this where we don't do randomness. We'll do like UVs or something. Okay, so this is all. This is all right. This will be. Oh. Okay, and then these will all be, man, I'm so almost close to being able to use this. So if I highlight these and hit C, I can do 16, yes. When I highlight these, hit C, I can do 24. Oh, 24. So now we want to like move, I don't know how to do this. There's probably some appropriate way to do this. Yeah, it doesn't paste, I don't know. It's like we replace instead of paste after. I could do this and hit C and hit 0, 0, whatever. Okay, and then these are all the topmost bits. I'm having them troubles. Okay. Now we can do Control C here, hit C, 1, 2, 3, 4, close that. Okay. So let's see how our randomness looks. The way we did the randomness was not very good because I don't really know the right way to do that. Yeah, why are the bottom... Why is there so much less randomness in the bottom? Also, why does this look like this? Why does that look like that? And not like... Did I accidentally have bitmaps on for this? Does not look like it. So that is RGB A8 unsigned normalized. That's 16 megabytes. And you would think that this would be 4 times that. because this is... Oh, no, they should be the same size because it is 4 times, because, yeah, we have 4 times as many pixels. Wait, are you showing stuff on stream? Did I miss it? What did you show? Was it good? Show me a sand jar. I need some kind of alert that lets me know when you're... I forgot that you had control. I thought you were in... I forgot you... Oh, yeah, look at that. Nice sand jar. I forgot that you were in control of the stream. You've got a lot of power. Okay, so we should just make it where there's like a little thought bubble that goes above my head, and then you can just show whatever I'm thinking at a given time. That might be unwise. So why would this be true? Is this just because I'm bad at picking random numbers? Could be. What if we did this instead of a random number? We truly just set it equal to I. Because it wants to be... Why can't I do that? No, David, you can't. I don't trust you. I built a thing. Kyle is like a... Somehow I've become Kyle's indentured servant, and so I built a thing for another channel that lets you like show images and play videos and things like that, which is very reckless. It's like a dangerous thing to let someone do. I should whitelist it where you can only play Buck Bunny. That looked weird. Look at that. Whoa. Look at this. That's an interesting result. Like, this is what's going on in the very bottom 8 bits. Like, you can't even see it here. Because this, I don't think this is black. I think it just has extremely tiny values. So this is what's going on in the bottom 8 bits. This is what's going on in the 8 bits above that. And this is what's going on in the 8 bits above that. And then the like most significant. Well, that's pretty cool. Weird. I mean, I'm sure we could figure out mathematically why this happens. Probably because we're counting 0 to 255. That's weird. Is it a problem because... Well, no, that's not that big. I guess, is this a problem? Does this have to be a UNT 32? Oh, but then this has to be a... Well, that's just absurd. How big's that int? 32-bit int. So it's the same, but it's signed? David, look at these beautiful lines. Why? Why is that true? I'm sure we're just seeing math at work here. This is not what I expected at all, actually. What I expected was that we would be doing like repetitive things across different color channels, you know, because we start counting at 0, so you'd think at first we're just counting up and having red at first. So why? This length isn't very big. Maybe that's why. Really, it should be like I... Cast these to float. You can stay in it. Nobody cares about you. Cast those to float. Why can't I do this? Whatever. And then multiply this times this. Cast that to it. That's a mess. Cast that to a uint. Weird. Why? 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 Does make a lot of sense. This makes more sense to me. This kind of makes sense. It's like, okay, I get it. There's like... It's going to be hard for us to actually know what's going on until we really try to... go back and forth. So I'm kind of wondering if instead of synthetic data, we should just find a like 32-bit, or like it's like 128-bit EXR, right? Where am I going to find that? $32 bits per channel EXR. Where am I going to find one of those? I guess I can just make one in Photoshop, right? Let's do that. Let's make an EXR and use that instead of the fake image, because I just don't know. Yeah, we could iterate through it in a different way, I guess, and like make some gradients or whatever, but it seems quicker to just do that in Photoshop. Welcome to Photoshop, Scott. Thanks, Photoshop. Welcome to you. Why are you showing the screen that I've told you 100 times not to show, where you show the recents? Where I've definitely told you never to do this. Why, Photoshop? Why? Okay, let's make a 1024 image. Let's make it very 32-bit. Let's make... This is going to be broken because Unity doesn't handle EXRs properly, but we'll just ignore that. Let's make two very fancy gradient layers. That, oh, it popped up over here. You know, so if we made like a very red to very no alpha, and it was very red at both ends. Is it said okay. I said okay. I said okay. I said okay. Oh, awesome. Thanks for that. Red. Delete this. Click OK. Click OK again. Delete this. I might have this backwards. Which one of you is supposed to be green? And then a very green. I want to set my 32-bit value, yeah. And the base of this should just be nothing, really. Are these set to... Should these be additive? Add? And add? Yes, okay. So this is like something like a 32-bit UV image, 32-bit per channel. UV. I might have gotten it backwards though. I did. The gradients go the other way. Oh, red is left, right. This doesn't really matter, I guess. Okay, that is more right, except I definitely have them backwards. 0. And this one is 90. Okay, does that look something like UVs? It's really weird, but maybe that's what 32-bit UVs look like. Just like, doesn't look quite right, but I don't care that much. So let's export N. EXR? Not a PNG. Not a PNG. I can't use the exporter for that. Cool. So we have to do a save as and EXR to desktop pixel pusher assets. So look at what this looks like, because I think when we bring it into Unity, it's going to be wrong. So we have this. Now we have it here. And we want to say what? Well, actually, it seems like it came in correctly. It just looked wrong here. Did I need to set some other... mode? Am I forgetting something? Probably forgetting something. We don't care that much. Okay, so we have a... we want to be very specific about our texture format. We explicitly, at least for the purposes... RGBA 32-bit? That's UNorm though. We want it to be in ridiculous float land, right? Can we not do that here? It doesn't really matter as long as we have a 32-bit texture. No, that's 32 bits. That's not right. We need 32 bits per channel. Can we not do that? Just from this dude? I don't know what this... unsigned float. I don't really know what that compression is doing to us. Why can't I... okay, a couple things. Don't be sRGB. We actually want like none compression, right? Compression none. Maybe we don't do this. We do this. RGBA 32-bit. I guess you can't. So if I say automatic, it's gonna pick RGBA 16 S float, which is not right. But that wasn't even an option in here. So how come they get to pick whatever they want? Was that an option in here? Because I don't see it. Like, I'm just not very clear. No, that's not per channel. Shared exponent float, RGB. Why? Like, this would be 16 per channel or something? I know I'm in maps. Why can't I do the thing that I want to do? I'm confused. Half is going to be 16. I mean, it's signed 16-bit floats. Why is there not a true 32-bit per channel option here? Doesn't that seem dumb? Like, why can't I do that? Is that not a thing I can do? Or did my export not actually do it? Let me double check that. In here, we're definitely 32 bits per channel, right? Well, we're only RGB, but I don't think that matters. 32 bits per channel. And we did a file, save as, EXR, we can't say anything about whether or not it's going to be. So I guess we can try to open that file in Photoshop and see. Because I'm a bit confused at the moment, frankly. Open it as... Well, that was weird. Open it as an alpha channel. This EXR came in as 32. So I think the file is 32. So is Unity just not letting us do that? Did you find something good? Is this cool? Maintainer needed is a bad sign. That means whoever wrote this doesn't care. It's abandoned. I don't know. I don't know. I'd use this. I mean, maybe I'd use this instead of After Effects. Honestly, if I was going to switch to something, I'd switch to Blender. Blender is also free nuke now. Did you know that? That Blender does node-based compositing? It's pretty weird. Well, this project is abandoned, it looks like, sadly. It says 6 days ago, though. Maybe they got it 12 days ago. Maybe they found a maintainer. Maybe that's them just posting the thing that says we're not going to support it anymore. But Blender now has... I know some people that have done this. Have switched to Blender for compositing instead of After Effects, which is pretty weird. It's a pretty wild thing to do. But I mean, it's not pretty because it's Blender. but people do it. People do things. Pretty weird. Okay, I feel fairly confident that the file is good. So is this? I feel like I've done this before. So why is Unity not letting me import a 32-bit per pixel? Oh, sorry, 30-bit per channel image. I'm almost certain I've done that before. Right? Right? What do I do? Because that's going to break my... It's going to break me. The format matters. Like, I have to have the right format. Well, shucks. So, never mind. We'll just write it, I guess. So we can do this like this. Which maybe we should have done this anyway. Like this. And then we know that RGBA is this. And I guess we could verify. Oopsie. And not put 1 in the alpha and 0 in the blue. You got booted while I was complaining. Why? I don't understand why I can't bring this in as an actual 32-bit per channel image. It's just not one of the options, which is real weird. I feel like I've done that before, but I don't see it. I have some dumb, whatever this is. I don't want that. I don't want some compromise thing. I definitely want 32 bits per channel. Why? I don't know. Okay, this is supposed to just have red and green set to do yellow. So that makes sense because we're doing the same thing. I don't know why the lower bits just aren't a thing. I also don't know why this looks like this. This makes it seem like I've really broken something. Maybe am I accidentally messing with the float pixels? Or am I like... So we got a float array. We're messing with it there. What am I doing? You would think that... Okay, so in one channel, just in the red channel, I want every pixel to increase in redness. So I need to divide this by 4. Is that my problem? 4.0. Maybe that was my whole problem. Sure doesn't look like it. Like, you can't even see it until it gets up here. I mean, this one looks cool. That's cool. We're very red down below, which kind of makes sense. Am I not counting high enough? We're trying to get, like, where we are. Is it this? Shouldn't matter. That was even worse. Why am I having such a hard time with this? What's wrong with you? Sure, of course not. Don't ever do that. U times that value, which I think is the maximum value, but maybe I'm just wrong. I mean, okay, wait. I'm thinking about this all wrong, actually. Whatever's going on in the lowest spot. Okay, I'm thinking about this all wrong. We're only going to see insanity over here because I don't know how to make a float value. I don't know how to like properly write a float. So of course this is going to be crazy. So the way to avoid that, yeah, okay. This is, I'm sure. Oh, it's supposed to be green anyway, but whatever. Okay. That doesn't seem quite right. Is that not the maximum value? Is it because that ends up being signed? Because I set the last bit? We really need like max float? C# max float or something. I'm spending all this time just trying to create the random texture to start with rather than actually doing the thing, which I think already works. I think that it actually is already working. Okay, what if I do that? Whatever. We're learning about the internals. How these things work, right? This doesn't make any sense to me. Melissa just did a really bad job, which I guess I could have done a really bad job. Because we say we want a float array of that dude, which means we said signed float, actually, which is S float a thing we can even have? Float's already signed. Okay. Okay, so what we actually need to do is this. Float dot, yeah, okay, it's this. It's this. I'm sure there's a better way to do this. Minus the float dot min value, which is the whole range of float. And then we just want to add this to float dot min value. I'm sure there's a better way to do that. Because that's silly. That's only a silly thing that a silly person would do. Still wrong. Still so wrong. Nice try. Nice try. Why am I having such a hard time with this? Index with what the width is. Okay, let's think about this for a second. So the index, wherever we are, we're counting up by 4. If we want to know the pixel index, we need to divide by 4, which we did here. Then we want to go to like XY coordinates based on that. So let me just make sure I'm doing that. Index to X and Y. Isn't it just... I've probably looked this up more than I've looked up anything ever in my entire life. Index mod the number of columns, which is 1024. Index divided by... That seems right. And then... Then we want like a normalized value for UV, which you'd think would be this. And then you would think if we took that U times the max value minus the min value, which would give us just some normalized range of the whole range of floats that you could possibly have, and then set it there. But it seems to not work. And you know, you'd think you would do the same thing. Again, this is silly because I'm spending all this time figuring out how to deal with this synthetic thing. But it's kind of, I don't really understand why I'm having such a hard time with this. I feel like it shouldn't be this hard. Right? It shouldn't be this hard. It should be easy. It should be so easy. Oops, one of you, you're supposed to be V. Although I think I have it backwards. G is U, R is V. Is that right? Like, you can see like 1 pixel is right, and then it go off the rails. Okay, let's just try. I don't know what to do. Clearly doing something very wrong. Could have been done with this a long time ago, except now I'm hung up on the fake data. Okay, where are we? Index is 0, so we're on like I is equal to 0, right? So index is 0, X is 0, all these are 0, U is 0, everybody's 0. Float dot min value is this tiny number. Float dot max value is a big number, it doesn't matter. So we're starting at the minimum value that a float can be. And that's great. We come back around. Index is 1. Doesn't matter. We're still on... Oh, well, that's not right. What is I? Oh yeah, it's 4, sure. So 4, now index is 1. So now UV is 1 out of 1024. So why is that 0? And not like 0.000097. That doesn't seem right. Is it trying to cast this whole thing to float after doing the divide? Now we're on index. We're 4 pixels in. Now we're 4 out of 1024. Okay, we're getting somewhere. So we're still on the first row. Skip through a few more. Yeah, so we're 17 out of 1024. So now we're like some small percentage. So you would think if this actually is our R value, that we have set it equal to something. Something that would almost make sense. Our Y is still 0. V is 0. We're setting this to 0 times this. I'm pretty confused, actually. And maybe that I just am really understanding this incorrectly. Because to me, it looks like we've got like 128 bits, but we're doing it in 32-bit chunks. So just out of curiosity. I can't believe I just can't draw a gradient. Like, what is wrong with me? So this is 4 million, which you think would be 1024 by 1024 times 4. Right? Because we have 1024 times 1024 times 4. Yeah. And so every one of those should represent one channel. So, and it seems to, like, I get red. Like, am I just way off base here on this, like, min value, max value thing? Is it not supposed to really be? It's definitely signed. It's a signed float. And it has the first 32 bits, which we're getting for, you know, if we're iterating over this like it's a bunch of floats, so we're not having to, like, shift or anything. What is my problem? What is my problem? I don't understand. Those numbers all make sense to me. That's a 4. U is going to slowly grow. I feel like I'm actually... Hey, David, are you there? David, can you hear me? Can you feel me near you? I don't think David's there. Hi, David. What is this? The texture format you're using, or are you using some big? When you're using float textures, you're using float textures, right? Is this the format you're using? This 32-bit signed float thing? RGBA float. Is that a thing? Oops. So that's not a thing for, yeah, it's texture format. So we can do that. But I think RGBA float is still RGBA float. (32-bit) 32 floats per channel. Well, those are still presumably signed. Those are signed values, right? Your floats are, you go negative and positive, right? Because you're in space. Yeah. I think this is the old thing. Texture format's the old thing and graphics format's the new thing. I think this is the same. 32-bit floats per channel, and this is 32-bit 32-bit signed floats per channel. So I think it's the same. I feel like my thing works. I feel like this actually works. I just can't tell because I can't get the test data to work. And I do not understand. I'm so confused. Like if, for example, I just said divided by 2 here. Am I sure? I'm pretty sure. 32 bits per channel either way. We're not entirely sure. But like I'm iterating through these. I'm treating them like they are floats, which would be individual 32-bit floats in this native array. And if I do half of it, it's half of it. So that seems right. Like I'm definitely talking about half of it. So I guess my math is just wrong here. I guess what I'm assuming, maybe this is wrong. Maybe my assumption is a bad assumption. Well, that still wouldn't be true because we're like blowing out too early. Like we're hitting our value, our max too early. We'd have to be hitting like full red or full yellow. So we're hitting 100% of the color to oh. Do you think that 0 to 1 is still the color and everything else beyond that is like magical HDR? But still, like, in terms of color, 0 to 1 is still just the color. That's probably it, right? It's normalized, but it can extend forever. Yeah. I should have known that. I still had this other logic. Yeah, of course I should have known that. Cool. Yeah, it was working the whole time. I was just scaling it. Because previously, when I was looking at it as an int32, it made sense to scale it. Okay, good grief. Why did I spend so much time on that? I was doing it right the whole time. I was just scaling it wrong. Okay, look at how crazy this looks. So this is the 32-bit value, the beautiful 32-bit value. This is the really high bytes, and this is like some bytes down, some bytes down. Now, the reason these are so crazy, I think it's because of the way that floats are stored in memory. And that's that one specification. I forgot what it's called. The IEEE, whatever. 7 IEEE floating point 745 maybe? This thing. So the way floating point numbers are stored in memory is there's like a mantissa. Mantissa, is that the word? And then an exponent, it's this. Wait, what is the mantissa? Is this not where a mantissa is? Am I thinking of some other thing? No, the mantissa. Okay, anyway. But it's stored like this, and we're doing something ridiculous with it. It's stored where there's some fractional value, like you've got 23 bits. I mean, this is an example of like, here's your some number in here, and then you have to what power you are raising that thing. And so we're doing something crazy where we're just saying like, give me these 8 bits and these 8 bits and these 8 bits and these 8 bits, and let us treat those as weird numbers. So these are the most significant bits. So those are what's in the exponent. And because I'm in the range 0 to 1, that's not going to change. Because I'm not changing by an order of magnitude. I'm always in... The numbers aren't big enough for that to matter. I'd have to go an order of magnitude more, I guess, to suddenly... what I was doing earlier, that's where we're seeing gradients up here. So this is essentially the exponent, which I'm to the... which is actually weird. I kind of would have thought it'd be to the 0th power, but... okay, to the first power? Or anything to the 0th power is 1. Is that right? So, and anything to the first power is itself. So that kind of makes sense that this would be to the first power. Kind of surprised we can see it at all. And then this is like the upper part of our fraction. So it's got this crazy repeating thing. I think you can have a sign on the exponent. I can't remember how to go negative. There's just some way to determine whether you go positive or negative in this. I don't remember. This is... Oh, it's here. You just have a sign bit. So actually the very top bit just tells you what the sign is. Oh, I see. But you're saying in addition to positive and negative, where do you go? I don't remember. I don't know. I don't understand IE 754. I've read through it before, but I don't remember. That is accounted for based on this. How you do like truly fractional. Well, actually, no, wait. If it's truly fractional, there's no exponent. You're just not. You just don't. Which is what we're doing. So then it's just whatever number you need to represent that. I might have that backwards. It may be, or that this goes higher to make it fractional. I forget which way it goes. But you see what I mean? You only need to go one way or the other. It may be that this is just a number, and then this guy is going to go up to say where the floating point is, or it goes the other way. I'm probably explaining that poorly, but I understand it poorly. The sign is just a single bit that goes here. That's the same thing for integer. Signedness is the most significant bit you just use to say if it's positive or negative. I don't know if floating point uses some weird, like normal in signed integers, things are weird and you've got to use 2's complement for negative numbers. I don't know if there's anything like an equivalent of 2's complement for fractions. I have no idea. Because, there's a separate floating point math is a separate thing. And computers used to not do it. You used to not have an FPU, but now you do. So I don't know if there's some equivalent to 2's complement. It would mean that this, so my top is actually these 8 bits. So it would just instantly make that number look very, very big. That topmost number, if it was negative, I think. Maybe we could try it. But I think if this is a negative value in here, that the most significant bit of my most significant block of bits would be negative. And so this whole thing will be bright yellow on the top, maybe. It won't be solid yellow, it'll just be much brighter. Yeah, so it's much brighter because we that block of eight bits that we're treating as a byte, we just said is now 255 basically, or not. It's 128 plus whatever else was in the bits, which who knows. So it's setting this bit in our land, the signed bit basically means that the color that we're grabbing from the most significant end here, that bit essentially is 128. So it's 50% gray. So we're seeing 50% and then a little bit more because other bits are set. Which is interesting. It's pretty cool to see this, like see how in memory these things are stored. And that's the thing that, so at the beginning of the stream, I was complaining that C# does not want you to look at memory, and it just doesn't want you to do that. But Unity actually gives you a way to do it, because that's cool. Look at that. The Unity native arrays just let you kind of say, hey, that piece of memory, pretend it's an array of this, which is it's what you would do in C or C++, is like, yeah, that like give me a pointer to some memory and I'm going to pretend it's an array of floats or whatever. So it's actually super cool that Unity lets you do that. I have some slight fear that I'm doing something that may not be. Actually, I don't. Maybe not. I think we're fine cross-platform wise. The only thing is maybe this is not a cross-platform thing. Maybe this isn't available on Android. But the same thing in principle would work with that R float, dude. So yeah, you're saying, David, to use texture format R, whatever it was, R float. This guy. But then what else do I need? Oh, that was interesting. I can set linear true there. Oh, I'm sorry. You're right. R float is only a single channel. RGBA float. Yeah. So I think this will be exactly the same, because we're just looking at it like it's whatever we want it to be. I don't know in a shader if you can necessarily do that. I have broken something. So that draws the same. Is R float only 16 bits per channel? It says 32-bit floats per channel. What did I break? We said get the raw texture format. I don't understand why that broke. Why would that be true? It's RGBA. Is it like some dumb thing where it's not really? Okay, have fun. I'm probably not going to stream too much longer. Any texture format. I can't believe it took me so long to figure out that dumb thing. Okay, RGBA float. Are you telling the truth, Unity? Is it really? It just says alpha texture, color and alpha, 32-bit floats per channel. And that was all fine. And that's our float array. Oh, wait. That should still be fine. I'm just looking at those at unsigned ints that are 32-bit, but who cares? Are those floats not... It says they're 32-bit. It says they're 32-bit. That's what it says. It says they're 32-bit. So why... 16 million is out of range. Seems like 60 million is out of range. It's a big number. So we're looping here through this native array, float texture in, but we're looping through it like it's a bunch of floats. Down here, we're looping through it like it's 32-bit integers, but that's the same. It's 32 bits either way. So, and we're stepping +4 every time. So why are you broken? This is making it seem like our int array is not big enough, which our int array should be whatever our previous dude was. We have 8888888. And we don't really care about that, what that is. Let's not do this. Let's be like non-fancy on this and do the that height, texture, format, RGB A32, and then no maps and be linear. Something still seems wrong. RGB A32. And we are looking at it as bytes. And it's 4 times the height of this. Same width, but 4 times the height. Oh no, what have I done? That's pretty weird though, right? How did we, is our offset wrong now? What was our float? This guy's length. These should be the same size, right? Or no, I mean, this should be 4 times. Yeah, this is 4 times this. So debug.log float array dot length, which should be the 4 million, and this should be 60 million, right? Why are you broken? $5 million and 22 million. Why would you be 5 million? What? What? Why would... I feel like is there like extra fluff going on here? What's going on? I don't like that format. I don't trust it. It seems like it's not doing the thing. That just seems wrong. How big is it here? Still correct, I would kind of imagine. No. What? It's like there's extra data there. Why would that be true? That's a little troubling. It's a little bit troubling. It's a little bit troubling. Unless it's like mip maps or something dumb at the end. We said no mip maps. Mip count and whether or not you're linear. Texture format, mip chain. Something I did screwed it up where there's like more bytes there than you would think. Now it's happy. Weird. Quite weird. Okay. Maybe it's the mip maps and it like gives it all to you. Maybe we accidentally had one level of mip maps or something by saying 0. I don't know. Okay. So, how do we now? So now we want to go back. So we kind of want to like break this up a little bit. So we got you and you're all happy. And now we got you and you're all happy. And now we want to try to get back where we were. You know, saying that if we now have the int texture, we can work our way back to float, which I think will be easy now because, again, the thing I was wasting time on was not an important thing at all. So what do we need to do now? Now we need an int array and a float array, but based on different stuff. Based on this new business. Int texture should not be inside this. Same really. Oops. Okay, now you're the out texture. This is gonna be amazing. So we need to iterate through, good heavens. Do we want to iterate through the float array or the int array? Kind of, to me, I guess it kind of makes sense to iterate through the thing where, like the source. Although we're iterating on them in such a way that it actually doesn't matter. The step is always the same. Okay, so what do we need to do? We need to be able to say that the float array, you know, I plus 0, good grief, equals whatever. Plus 1, plus 2, plus 3. Green, blue, alpha. I'm gonna make sure it runs. So, you know, if we set red to 1 and then alpha to 1, then we should see that be solid red. Right? That was a weird idea. It was a weird thing to do. You're not solid red. Why aren't you solid red? We're getting the raw texture data. Because we want to talk about you like you're a float now. Maybe we'll change this back, but for now, let's talk about it like it's a float. In fact, we need to change it back, but for a moment, it's a float. Yeah, that's right. Okay. We're not going to talk about it like it's a float for a minute. So what do we need to do? We need to get 4 pixels back. So we know how to get the first one. Is easy. It's just the same indices. So it's from the same place. This is a weird one. Because we need like RA, RG, RB. I'm trying to think of how explicit to be on this and how much to just streamline it together. Like, could we reasonably do this in one? I don't think so. Let's just have an int RA. Well, wait, what's wrong? Good grief. All right, okay. An AA. And that's right. And then for each of these, now we need that. We gotta have that same offset again. We don't have to calculate this every time. Whatever. And we just need to do the same goofball thing. Okay, so that means get the RGBA A value. That's like from our upper, or in this case, our very bottom quadrant. Once we kind of get this down, maybe we'll try to see if we want to combine it a little bit. This is B, and this means the offset is there. Oops. I was wrong. These are all ones. Why do I keep doing that? Okay. Oops. I don't like that it took me back to the beginning of the line. Annoying. Okay, we have all of these things. And so to make this into a thing that matters, we have to take RA and no, we want to OR them together. RB shifted by 8. I think this is right. Or RC shifted by 8. Or RD shifted by... I mean, year 16. Just to be so explicit, it's silly. But pretty sure the compiler will throw that away. What's your problem? An int to uint. Excuse me. I want to stop streaming soon. Hopefully this works. Then I'll stop. Maybe we'll pick up tomorrow. What are we? UN32? Right? That's a pretty good looking red gradient. Okay. So we just need to do the same thing. And then this turns to, oops. R, G, B, A, B, B, A. Do we want to try to make this less? I don't think it matters that much. It's just a very explicit, but that makes it easy for me to look at, and the compiler just probably doesn't care. Doesn't care. Okay, we were able to take this 32-bit image, split it into this insane looking 16-bit image or 8-bit image where it's 8 bits per little quadrant, and then reassemble it back to a 32-bit image. So it's a pretty weird thing to do, but I think I like it. As far as trying to do that on the GPU, the biggest challenge is like the types. Like dealing with the types is really, unless it just lets you do bitwise operations on floats, you know, like maybe it does. Maybe you can in a shader. So maybe this is actually way easier in a shader. I don't know. Do you know? Get out of here, UV image. You're never getting any good anyway. So I don't know. If you had something that was like float whatever equals 1, can you do this? I don't know if you can do stuff like that in a shader. Probably not. You do this. Definitely do that. So can I do on a float? No. So that's pretty lame. So this may not actually be a thing that you can... Float bits to int. Whoa, is that real? Is that real? There's no way that's real. Yeah, because we need to be an HLSL. Like, I just want to be able to get to the bits. I don't want to round. Float bits to int. Have bit encoding, so what? Get number bit set. I just wondered if we could look in here and figure out if there was like a thing. Oops. HLSL compiler. I don't want to cast. I want to know how to... lame. There's not a way to just do that in HLSL? And with native arrays, it doesn't matter. Because as we've seen, we can just like get those however we want, but like in a shader, it seems like a thing you should be able to do. I don't even really know what to look for. I don't really want to cast, well, binary casts as float. Binary cast. Casting operations between the float will convert numeric value to the appropriate representations following two rules. Casting value. Binary casts. Okay, but is that... Which reinterpret the bit representation. So can I say as int? Just for a second, call that float. Ooh, I think I can. Okay. I'm probably gonna stop soon. Go for a walk in the gloaming. So maybe we'll do this again, and then we'll try to do it on a shader, in a shader tomorrow. Both ways. So this is very verbose because I wrote it to be very verbose. Of course, you could like shorten all of this and cram it onto one line, whatever, but I kind of like it like this because you really see what's going on. You get into a bunch of pixel values and cramming them in. I mean, I might even name these more explicitly. Would be my style. It's kind of nice that you can get them straight out like that. There. Because we're really doing like, I don't know. You kind of make the case either way. I don't know that I think one's better than the other. In terms of like treating it like I'm talking about a pixel or I'm talking about the channel. Like this, you know, we need all the R's together and they're split here. So you could reorganize this and get all the R's at once, but whatever. It's not that big of a deal. Okay, so so this was just the synthetic data. So it's really, it's not any math. It's just, we took a lot of lines to do it, but it's so nothing. It's like, this is the value we start with, and then we just want to put that value in 4 different pixels. That's all. And on the GPU, you know, of course, this would be like a vec4. So we'd already have these as just like the vec4 values. We'd have to do a little bit of weirdness, but not that bad actually with the UV stuff because of the way I did it with the offset. You would just be offsetting the V. So I think we can do this in a shader. Maybe we'll try it tomorrow. Anyway, Kyle, David, thanks for stopping by. The weird people posting strange pornographic ASCII art at the beginning. Thanks for hanging out. Oh, David, you're back. Oh, Kyle, you stuck through it with all of this nonsense. I'm impressed. This is a boring stream to begin with, and then I struggled with something that was boring. Yes, so David, it works. It works, and it's actually really fast because it just uses the like native pixel representation. You still have to apply it, but the CPU side is quite fast. Because you can get the raw pixel data, and it's just you're pointing to that memory, which is pretty cool. So this is the original, this is the intermediate, and this is the outside. And what I was just trying to figure out, oops, I'm sorry. I should look at this thing. Let's look at it again. Yes, this is the original. This is the intermediate representation, or weird representation. We got a nice uppercase T. And this is the restored, which should be lossless. I mean, there shouldn't be any loss. So and then what I had just started to do is figure out how you do it in a shader. And it takes a trick that I didn't know of, which is this. Values over 1 just blow out. They'll just blow out. Same for negative. You just won't see them. I mean, we can just put it in there. If you want to see it. It'll blow out on the original textures, but it'll look cool on the secondary texture. So if we just go in here and say, you know, between 0 and 100, then our texture will blow out yellow, I think. Yeah. But then you can still see all the stuff going on in here because all the data is still, it's still there. It's all still there. These are kind of cool. These UV, it'd be interesting to draw something with these UVs because they're weird. Okay, so but you know what? You know what this looks like to me? You know what this looks like to me? Is like the way this scales reminds me of the scaling I was having, the weird scaling problem I was having with EXR. Like where things were getting clumped in a weird way. Definitely gamma-ish. But maybe not really gamma, you know, something that's not quite gamma. I mean, you know, something exponential, but not the actual gamma. Oh, yeah, because you know what would happen if, for example, you thought you had 32-bit EXR data, but it was actually 16-bit EXR data, but you were treating it like 32, that would throw off the exponents, and maybe you'd have something weird like that. Maybe. I don't know. Like if the bits were interpreted wrong, maybe you'd end up with weird clumpy things. Because essentially like an exponent was in the wrong place. I don't know. I could maybe see that happening. Maybe. Anyway, so the cool trick on the shader side, I'll try to do a shader version tomorrow, but the trick will be this, which is not a cast of a float to an int. It is a treat the bits of this value like it is an integer, which would be essential for the thing we're trying to do. Are ints all 32 bits here? We might have some problems actually. Like, can you have a byte in a shader? Like, I don't know what all types you can have. It actually, we might have some like slightly hard, not super hard, but slightly hard problems to solve. Or maybe they won't matter on this. So anyway, we'll try tomorrow probably to do it in the shader. It'll be so fast. It'll be so fast. Okay, Kyle, David, thanks for hanging out. Thanks, pornography people. Talk to you later. Goodbye.